Hello and welcome back again for another tutorial about AI UI. In this tutorial I'm going to talk about transformation nodes and how to use them, because transformation is crucial for machine learning problems. Most people forget that training a machine learning model is not about the neural network itself. I would say about 70% of the whole workload is just about encoding, scaling, saving the encoders and scalars for later usage, as well as transforming your dataset. You don't need all columns. You don't need all rows often, or you have to fill empty cells and so on. So transformation, encoding, scaling, and so on, data pre-processing is the most important part of machine learning. And for that, we have implemented several nodes to achieve your goals. So to show you about the Append node and how it's working, I will import the same dataset 2 times. It's just to show you how it works. The iris dataset is widely known, so simple and on point for this tutorial. Let's drag and drop the append node. The data socket is the socket, or is getting the data set that has to be first if you prefer one over the other, and the append data set is the second one. Right now we can choose just two options, rows or columns. That's the most that's the only, we can just choose about rows and columns. That's all. You just choose, do you want to append the data set column wise or row wise? Okay, and with this checkbox here you can choose if you want to ignore the indexes or not. So let's just do it. We will ignore the index and just add one dataset to the other. If you choose append data for rows, you have to have the same amount of columns. Okay, and if you want to append two data sets with columns, column-wise, via columns, then you have to have the same amount of rows. That is to mention right here. So what we have done here, we just took these two similar data sets and added the rows. Nothing more, nothing less. So you could also do this, proceed, and you will get the same result. Just wanted to show you, okay? Now let's go on with drop index. The drop index node is designed just to drop rows. To make it easier, we'll just drop the first two rows. Like this, you type in the row count you want to drop, and go on to proceed. And what's happening here is you see how the first two rows have been dropped off. I typed in from 0 to 2, and that means row number 2 is not involved, okay? You have to mention that. Let's go on with drop columns. That's also a very easy case. You just choose columns. If you don't connect any data set, you should not. Here, okay, it's in there, but there is no input connected. You won't be able to proceed even if the list is already loaded. You have to connect the nodes, and then you can choose the data set the columns you want to drop. let's just drop everything without besides one column, and all you have is one column left. And you can see it also here in the shape. Yeah, that's really important to mention. Okay, drop an A and fill an A are nodes to fill or drop missing values. And here you can choose if you want to do this column-wise or row-wise. Also, you can choose how many you want to drop if you have any threshold for this. And if you want to fill the missing values, you have to type in here the value you want to replace it by. For example, if you want to fill an empty cell with O, you can just type in O here and proceed, and you will see that all empty cells got filled with O's. The last transformation node right here is similar to drop index, but you don't drop anything, you replace values. So we will skip through the data set and pick a value. Let's take this 3 here, and we take it and we replace it by, let's say, 81. We add it, we proceed, and as you will see right now, 3 is replaced by 81. That's it in this tutorial. Next time we will talk about encoding and scaling. Thank you.